You're welcome once again to the channel and my tutorial series on creating linked list and how you can easily have your own linked list, how you can understand the concept behind it and have all of those methods on your linked list. So in the previous video, I discussed on us creating just a singular node just like we have here, and every linked list is actually a link of connected and related node all together, where you get to map them, and that is one of the flexible way of you having and working with your list item. So we created just the node as you can see right here on my VS Code, and we were able to add node manually link them together. All you need to do is to call on the next to the previous node you have, and that will link your new node to what you already have on the list, and that gets stacked all together. And if you want to add 5 items, you need to get the .net, so you need to keep on adding that. That might be quite straightforward and easy for you to implement, more especially if you don't have more item on your list on your collection. So what if you want to add about 100 items or 1,000 or more? You can imagine how stressful it would be for you to have the .net. And what if you want to find if an item exists on your list, whatever. What if you want to insert at a particular position, and you want to have all of that. And then some couple of methods you want to implement, just like all the methods we have on your array. We have the pop, the push, the unshift, the shift, the define, the index of, and all of those methods. So that is what I want us to implement using linked list on this tutorial section. And for that, what we need to do, we just need to create a class, right? And within the class constructor, we can get an instance of a node, right? Because a list will actually contain an instance of a node, and upon each of the node we get to within the class, we can go ahead and add all of our methods in there and define the add, the unshift, and every of those methods you have there on your list. So I'll create a class now, and I'll call it I'll call the class linked list. Let me just remove this. I think we don't need that now, or let me just comment it. That will be fine. Okay, so I need to create a class, and I'll call it linked list. Okay. Now within this class, within the constructor, I need within the constructor of my linked list class, I just need to set the head, right? I just need to set the head to a node, and I can just give it and a value, and all I need to say right now is have the constructor, and now within that I can have this dot head if I want to call that. I want to call that to be new node. We have the class of new node, so we're creating an instance of the class there, new node, and I need to pass in just a value. I want to just call this a head. Excuse me. So I just want to call that the head, and that is my basic node, and I just want to call that the head. All right, so now this is practically what I'm trying to do. I want to have the head. I just want to create just a head variable here. All right, this is way too big. Let me reduce that. So I just want to have the head there, and I want to have a head. All right, so that is the basic thing I want to have within my class list. And whenever the head will start pointing to the first item. Now if I want to remove this as the head, all I need to do is to point my head to somewhere else, all right, on the list, and that is all I need to do, and that is what this class is all about. So we have just the class and then the head, which is a null for now. And if I come here and I say let's list equal new linked list class, and I have just the empty instance of that. If I try to print list, and this is what we have. So we have just the head for now, and the head is not pointing to anywhere on the node. Okay, now if we want to add more items, so we can have a method there that will insert into our list. If we want to remove, if we want to display all of our items, we should be creating the method very shortly. Let me remove this comment. Okay, right now let me create a method that will enable the user to insert into the list. For that, within my class, I'll create a function. I'll call that insert, or you can call it add, or whatever you want to have it. And for a user who want to insert into that, we just need to pass in the new element the user want to pass in, and then the item also. We need just these two variables for our method call. All right, now we need to for the new element the user is passing in, we need to create a new node for that. And once we do that, then we need to find the current node. Okay, and then all we need to do is to make the new node the next, right, to be to be that's our current node next. So that is basically all we need to do, and this is what I'm saying. Let's create a new node. I can call that let new node is to be equal new, and then we have our node, new node of the element user is passing this time around, of new elements. All right, and so we've now created a node just like this. That is what we are doing there. We're setting the value to be the element user is passing in, and then the item we want to put in within that node, which is the value in here, which is this new element. And then the next thing we need to do is to get what our current node is. Let me use the const once again. Let me call that const current node. I want to get that to be this dot find. We should be creating the method shortly. This dot find, and then we want to find the item. All right, so yeah, what we want to do, we want to insert at a particular position within our node. So find the item, that is the current node, and once we get the item, that's the position of where this item is, we want to push in our new element next to this item. Now this is what I'm trying to talk about. Let me remove this. Okay, so now let's assume this to be our head, and then we have this list going this way. Right now, what we're trying to do is we want to insert this new element in this position. So now what we're trying to do is we want this node to point to this instead of pointing to 4, and then this can then point to the previous item where this is pointing towards at the first time. So what we're trying to do is we want to remove this arrow from there. We want it to point down this way, and this we want it to point from here. This right here, we want it to point here. That is exactly what we're trying to do. We are trying to insert this in within these two items. Now the item we currently have is this, so we are trying to get the position of this item, and then all we need to do is to say this item right here dot next should point towards this, and then this should point here. Now this will not point to null anymore. This will hold the address of the next item. Let me see, that is xb998. Okay, now these are just some randomly assumed address. I'm putting it right there. So that is basically what we're trying to do. All right, now first thing is we need to create a node of the new element we're passing. Then we need to find the current node, right? That is this item. This is the current node where we're targeting, because that is where we want to pick our points from and then send out from there. So that is what we're doing here. .find. We don't have this find method yet. I'll be creating that shortly. Now let me get before we proceed, let me create the find method, and let me have find that will take in an item, and then here within the body we need to first of all get head. Let's current node to be this dot head. Every time you're trying to work on linked list, you need to target the head, and from there you can proceed to your dot next to arrive at whatever value you want to get. Okay, so we have this. I've gotten the head this time around. Then this is where we just need to run a while loop, and while we keep on looping through until we arrive at this once we arrive at the node which have the value of the item we are looking for, and that is where we want to stop. Okay, so let me bring in the while loop. I'll have while I have current node dot element, while the current node dot element, while it is not equal to item we should have within the body. We want to keep going forward. We want to set our current node should be our current node dot next. Okay, so we'll keep looping up till then, and then once we arrive at that, any value that's once this condition is once we arrive at the item we're looking for, then this loop it will break out of this loop, and we just need to go ahead and return. We just need to return the current node. So that is basically it. Let me explain the code to you once again. So the find item is just looking for any node with that item, right? And what we're saying is now keep checking through the element. Remember, on each node we have two items. We have the element and the next address. So now what we're doing is we're checking the current node dot element, right? We are looping through each of this lists rather. Right now, take for instance, if we're looking for 15 here. Now what we're doing is we're checking current node, right, dot element. We're checking if that is equal to the the item we're searching for, right? And we keep through the list. We keep scanning through the list until we arrive at that. Now what we're saying is while the item is not current node dot element, keep iterating through, right, and just keep going through all of the list. And once that statement kind of get falsy, right? Once you break out of that, that means we've finally gotten our current node. Then go ahead and return that node. All right, that is what we're just trying to do here. That is what the find method is basically doing. All right, now we can go ahead with our method for the insert new. So we've gotten our current node with this method, and the next thing we need to do is to set the current node dot next, right? So I'll have I'll set the new node dot next equal current node dot next. All right, and we have that. Then we need to set current node dot next to point to new node this time around. Current node dot next equal new node, and that is basically it. Okay, That is basically it. I will go back again to the board and show you what I'm trying to do here. All right, now remember, at the first instance, this was what we are having. Okay, and let me remove this. Okay, so now this node right here was actually not part of the linked list item. So now what I'm trying to do here, what I'm trying to explain, or what I'm trying to implement is this. We want to insert this node here within this position. Okay, so now we use the find method to get 13 because that is the item we're searching for. Now after getting that, then the next line is to pick up this node. These are new nodes we want to create right here. This time around we want it to point to this. All right, that is the first thing we did there by saying because that was where our current node was actually pointing to. So we said new node.next point to where current node.next was initially pointing. So this one, so stopping at line 23, that is exactly what we have. Okay, so we said current node.next also points to what new node.next rather should point to what current node.next is pointing at. All right, and once that is successful, and if we stop there, that is exactly what you have, this pictorial representation just like I have it here. Now on line 24, what we are now saying is we are now removing this node instead of pointing down here because this is not linked at the moment, right? What we're now doing here is we're now bringing down this arrow. Don't point to this value anymore, rather point down here. All right, so that is how you insert very easily on your linked list. All right, just get the position of where you want to get, where you want to insert, then the new node should point to where that item was previously pointing to, and the current item should point to your new node, and it's as simple as that. Now we're gonna be testing and be printing our node to see what we have, but for us to get that, I want to create the display method so it can print us all the node we have and we can see our output. Now for the display, we just need to look through all of them and just console log all of the nodes. So for that, let me have that third method here. Let me call it display. This is basically not taking any inputs. Then within the body, first thing, remember, as I said, whenever you're working on a loop, on a list, rather, whenever you want to find or you want to kind of run through some iteration or whatever, you need to get the head and you start from there for a singly linked list, right? You need to get the head, the target head, and then from there, from the head, you can get your current node.next, and you can continue all your loop all through. So for the display, same thing we have to do. Let's head, want to get that to we can call that head or we can call that current node, but let me call it current node so we don't mix the names. We call this dot head. Okay, and we have that this dot head. Let me collapse from this method together. Remember, in the constructor, that was our starting point. We call ours head. All right, if you want to call that start, you can go ahead with any name you want to give that. So we have the head. Now I'm gonna do while. I'm gonna have a while loop there while our current node, while the current node.next, while that is not equal to null, right? That is why we are not on the last list of the node, right? While we are not kind of shooting outside of our node. Now all what we need to do is let me just console log the output there, right? Just want to print it there so we can see the result. I just want to log current node dot elements. That is what we want to see. Want to get current node dot next dot element. Okay, now we're not just starting from current node dot element immediately because remember we're starting from the head, just like this diagram I have here, and we just so now the head is just kind of a position that where we're having linked our list from, and we just want to, this is where our items start from, right? So we want to get from the next dot element and we'll keep on all of that in a loop. Okay, and now once we have that, we need to set for a loop to increment. We need to set our current node to be equal current node dot next, and that is all we need to do to display our nodes. All right, so now I have my list instantiated. So now let me add some item. I can just go ahead and use list dot insert list dot insert. What do I want to insert this time around? Okay, I think we have 12. I have 12 added, and I want to put that at I want to put the value 12 at next to the head. So all I need to do is to pass in head. Okay, and you can see 12 is coming next to head, just like we have it on the insert there. All right, now if I call on the list.display, and just call on that method, you see we have just the 12 being printed here. Now if I call on this once again, if I call on list dot insert, what do I want to insert this time around? I want to insert 13, and want to have that next to 12. Okay, and you can see that 13 get appended. And what if I want to insert, let me just duplicate that. Want to have 15 this time around. I have 15, and that is coming next to 13. All right, so now you can see what is happening here. Right now, if I try to put 15 after 12, now if I put in 12 there, you can see 12 is coming before 15. Now that means I want this to point here, and indirectly, remember this was pointing to 13 before. Now what will happen is 15 will now point to 13. All right, so that is what this method is actually doing. So let me change that to 13, and lastly let me put the last item on my list, which is 15, now coming after 13, and I want to add 4, and 4 is coming after 15 on the list. All right, now you can see how simple and how easy that was, and that is how you can have your insert, how you can display your method, how you can find an item on your linked list, and all of that. So that is in a very easy way how you can implement this. I'll give it a pause here. In the next tutorial video section, I will discuss on how you can have the find previous, how you can remove an item, and how you can even add an item at the end of the list, because the insert method we have here shows the user how to insert a particular list or a particular node in it could be in the middle or in any position on the list. That is what this insert method is doing. Now, just like with the way we have the push method on array, right, I want to show you how you can remove the last item, and that is very, very easy and straightforward. All you need to do on the practical presentation is this item right here. We just need to make it to point to null, and that is how you remove the last item on your list. And then that is how you remove the last item on your list rather. And then for the add the last item, all you need to do, get your node, and then the last item there should not point to null but should point to the new node we should add it. And that is how simply the process and the flow goes. So thank you very much for sticking around. Please like the video, subscribe if you're yet, and hit the bell icon so you get notified whenever I make any video, and then whenever I make any have any updates on my channel. Thank you very much for sticking around, and I will see you in the next lesson.